This is my solution for the hiking trail free response question. I'm assuming that you've gone ahead and you've read through the question, you understand what's being asked. This particular question deals with working with data inside an array and using some of the common array algorithms. So we'll start with part A, which asks to determine whether or not a particular trail segment is level. And the problem statement here asks that any trail segment whose difference between the max and min is less than or equal to 10 meters will return true. Yes, it's level, and it's false otherwise. So a couple things to be aware of is we need to find the maximum elevation as well as the minimum elevation. We've done this plenty of times, finding a max or finding a min through an array, so you should be comfortable with this. The only difference here is we're not always starting at the first element of the array and going into the last element of the array. Instead, we are given indices as to where we should start and where we should end. So you should be thinking here, well, instead of starting at index 0, I'm going to start at index start, whatever that may be. Maybe we'll start at index 2, maybe index 4, maybe index 5, but that starting spot will be represented by the parameter start, and instead of going all the way until markers.length minus 1, we'll go up until the parameter end. So with that in mind, let's go ahead and write up our solution here. Since we know we're going to need to have a maximum and a minimum, and we want to store those values, we're going to need to use some local variables. All of the values inside the markers array are integers, so all of those values will be ints. So now the question is, well, what should we assume those values to be? If we assume that the maxes and mins are at an elevation of 0, then we are neglecting the possibility that something might be below 0. Best practice is always to assume that your max or your min is the first element inside your array. So for us, that will be markers of, and again, we're not saying markers of 0, instead this method begins at the index known as start. So we'll assume that our max is at the beginning, and we'll also assume that our min is at the beginning. Okay, so now we're ready to go through the array to find our maximum and our minimum. Once we found our max and min, then we can go and determine whether the difference between those two elevations is less than or equal to 10 meters. So we'll traverse through the array to find max and min, and after that is max minus min less than or equal to 10. Alright, so this is a standard for loop here. Again, if we were traversing through an entire array, we'd start at index 0 and we'd go such that we are at less than markers.length, and we go up by 1. However, we're not starting at index 0, we're starting at index start, whatever that parameter is, and we're not going to go until the very end of the array. We might if end is of a particular value, but otherwise we're going to go as long as I is less than or equal to end. And again here, if you read in the problem statement, the value of end is a valid index because a precondition guarantees you that end will always be less than or equal to markers.length minus 1, keeping in mind that markers.length minus 1 is the last valid index of this array. So it's okay if I is equal to that end value. Alright, so now that we're inside our for loop, we need to see if we can find a new maximum or a new minimum. So to do that, we see if markers of I, that's our current index, where we currently are in the array, if that is bigger than our max variable, then we have a new maximum. If this value is less than our current minimum, we have a new min value. And I'm neglecting the curly braces here because it's a single statement inside the conditional body, so that will just save us a little bit of space. That should say else if. Alright, so when we hit the end of this for loop here, we've gone through the entire array, we found a new maximum value, we found our new minimum value, we've assigned those to our two local variables. And now the last thing we need to do is simply determine whether or not the difference between those two is less than or equal to 10. So if max minus min, if that is less than or equal to 10, then we will return true. Otherwise, we will return false. You don't have to use the math.absolute value method in here because max will be greater than min. So that is part A. And now we'll need to move on to part B. Is the trail difficult? The problem statement here says that if we'll need to determine the number of changes in elevation that are at least 30 meters up or down. So again, if the difference is at least 30 or at least negative 30, that counts as a significant change. So that should kind of be a cue to you that you're going to need to use the absolute value function here. And then at the end, if we have at least 3 of those changes, then we will return true, otherwise we will return false. So you can see here 150 minus 105 is, well, we have a difference of negative 45. And here we're going from 100 to 150, we have a difference of positive 50. Both of those would constitute as significant elevation changes. All right, so this time we are going to have to go through the entire array, so we'll use a regular for loop, but we also need to keep track of some kind of counter to determine how many times we have significant elevation changes that are at least 30 meters up or down. So we'll begin with our for loop, starting at the very beginning of our array. Now something to keep in mind here is we're going to need to do a comparison of 2 elements next to each other in an array. So we're going to look at the element at index 0 and then the element at index 1 and compare those two. So if you've got this for loop in mind, you should be thinking, well, if I is equal to 0, I want to also look at the element at index 0 plus 1 or index I plus 1. So anytime that you're accessing an element and then tacking on plus 1, that's going to change our loop bounds. Right? So if I is equal to 11 later on in our loop, and we look at I plus 1, well, I plus 1 should give us 12. We need to be careful here, however, that we can't let I equal 12, because if I equals 12, then I plus 1 is 13, and we get an out of bounds exception here. All right, so inside this for loop, rather than saying markers.length, that's going to need to change to length minus 1. So that's a really important FRQ skill to keep in mind, is that if you're doing comparisons, either like a plus 1 or minus 1, that's going to change your loop bounds. So this will become I plus plus. We'll go by 1 every time. And so now we simply want to compare if markers of I minus markers of I plus 1, the difference between those two is greater than or equal to 30. Then our counter will go up by 1. This is keeping track of how many times we have a elevation change of 30 or more. Now we saw here that both there's positive and negative elevation changes. So how do we adjust for that? Well, simply the only thing we care about is the absolute value here. So in our conditional, I'm going to change this to math.absolute value. This will guarantee that we'll always get a positive value for the difference between 2 elevations. And if that absolute value is greater than or equal to 30, then our counter should go up by 1. Again, it's because of this I plus 1 for an index here that we have to change the Boolean conditional, this upper bound here, to come down by 1. So that way we don't get an out of bounds exception. So once we reach the end of the for loop, we have traversed through the entire array and we've done all of our comparisons. And now if the counter, the problem statement here says if there are 3 or more such changes, we will return true. So if counter is greater than or equal to 3, we'll return true, else we will return false. And that is it for the hiking trail free response question.